We will see that how NFA can be converted to the DFA. This is the theorem which says that for any NFA M Q sigma Q0 A delta accepting a language L which is taken from the sigma star, there is a DFA deterministic finite automaton M1 Q1 sigma Q1 A1 delta 1 such that the language accepted by the DFA is same as the language accepted by the NFA. So for any NFA, this says that for any NFA you can convert into the DFA. Corresponds to any NFA, we will have some DFA. So now question is that how we can show that how the conversion means how we can convert from NFA to DFA. This means you need to think about the states of the DFA, and also you have to think that okay, there is some initial state in your DFA and you have some final states, and you need to define the transition function of the DFA. So how we can construct these states and transitions for the DFA. So you know that in case of the NFA, you have the transition function in the NFA delta. What is the transition function in NFA? This says that you have some states. From any state, you have some input, and you have to go to 2 raised power q, means subsets of q. So any subset of q from any state for any input, your machine can go to more than one place, means more than one states it can go for the same input. So here 2 raised power q, it can go to any one of the subsets of q. So 2 raised power q denotes all subsets of q. This is the set of subsets of q. So once you are going to convert NFA into the DFA, then all such the kernelity of this set, actually this much number of maximum possible states you will have, means you can define the q1 can be equal to 2 raised power q. So q1 is the set of states in the DFA, and you have what are the possible states in the DFA? 2 raised power q. This means you have all possible subsets. So you have all possible subsets of q, means your machine, in case once you are going to convert, your machine transit from one subset to other subset. This is the maximum possible number of states in the DFA. However, you may have fewer states as compared to 2 raised power q. So we will say that among all such 2 raised power q states, your DFA may not go to, your DFA may start from the initial state, and it may not be able to visit all such states. So, but the maximum possible states in your DFA is 2 raised power q, because your NFA goes from any state for any input, it can go to the any subsets of q. So once it goes to any subsets of q, then to ensure that from that subset, if you get some input, then what is where you can go, means which is the subset of q where you are going, and that subset is the states of your DFA. So you have defined the q1, the set of states in the DFA. You have defined q1 as 2 raised power q. Initial state, your machine, your NFA is going to visit, start from the initial state q0. So you have initial state here. This is the initial state, and your machine should also begin with the q0, but you have to write in the form of the subset, because any states of your DFA is in the form of subset. So q1 is actually q0. So your machine starts from the q0 actually. Now we need to define the transition functions. So transition function is important in case of the DFA. How you can define the transition function? So for any state, for you can say for any q which is taken from the q1, Q1 is the set of states in the DFA. For any Q belongs to Q1 and A belongs to some input symbol, A is some input symbol, we can define the transition. Here transition of DFA is what? We denote by writing delta 1. So delta 1 is the transition of your DFA, and you can say you are in the state Q and you have the input A. You need to define the transitions. So Q can be any state of any states of your DFA. From that state, if you have some input from the sigma, you need to define the transition where you can go, because we know in case of the DFA, you have to define the transition for every input from every state. So Q is the state actually of DFA, but Q actually is what? Q is actually some subsets of Q, some of the subsets of Q. So here actually Q is some subset. Maybe you may have one element, or you may have two elements, or it may have three or four. So Q is actually the subset of the Q. So this actually Q is the set, which is the subset of actually Q. So you can say that Q here we say that Q is one state of the DFA, but states of DFA is every state of DFA is a subset of Q. So you can say that Q is a subset of Q. You can have one element, two element, or three element, any. So Q is any subset of Q. So see, if Q is any subset of Q, and Q is what? Q is the states of your NFA. So you can say if Q is, you may have two states like this and this. So this is one and this is other. And from here you are getting some input symbol, and from here you are getting some same input symbol. So your NFA can go to some places. Here also you are going to some places. And so what you need to do, from this state in the NFA, for the input A, you are going to some place. And from the next state of your NFA, you are taking the A, you are going to some state, and then make the union. Then this is the subset. You can say that from this subset, you can transit to this subset. So you can define the transition of DFA on behalf of the transition of your NFA. So you can say here union. Delta is the transition of your NFA. You have the P and you are taking the A. Where P is what? P belongs to Q. So this is the definition of the transition function of DFA. P belongs to Q. Means, and you know that P is some subset of Q. Means for every element of this set, you need to see that from that element, from that state, if you have the input A, where your machine goes, and then finally you can make the union, and this is you can say that from this state your machine, in the case of the DFA, your machine goes to this state. So this is the way you can define the transition on behalf of the transition of your NFA. Now you can define the set of the final states in case of the NFA. So you have the NFA. A1 is the final states of your NFA. How you can define the final state? This is the set of Q, which is taken from the Q1. Q is the any state of your DFA, such that Q intersection with A is what? A is the accepting states of your NFA, is not equal to null. So this is the way you can say you are going to make the transition. This means what? You have to mark every subset of Q. Q is any subset of, you know that Q is any subset of Q. So this Q is actually an element of DFA, any one state of your DFA, and means this is the subset of Q. It can have the elements of the Q. And if you make the intersection of this subset with the accepting state of your NFA, and if it is not empty, this means there is some element in the Q which is the final state in the NFA, and hence this will become the final state in your DFA. So all such states in the DFA, all such states Q which is taken from the Q1, if you found that Q1 intersection with A is not equal to empty, then they are the final state in the DFA. This is the way you can define the transitions. So here actually for the conversion of the NFA to DFA, we have seen the set of states in the DFA. We have also seen the initial state of your DFA, and you know that how you can define the transitions of your DFA on behalf of the transition of your NFA. And finally, we have seen what are the accepting states of your DFA. So this is the construction of your NFA to DFA. Actually, what you mean by this? Here you have the DFA, and this is the transition function, and you mean that if you are at the initial state of your DFA is Q1. So this is the initial state in your DFA. So, and from this initial state, if you have the string X is what? X is any string which is taken from the sigma star. So if this is the, you need to say that this is this conversion says that if you are at initial state of the Q1, states of your DFA, which is the initial state of your DFA is Q1, and from that initial state, if you have the string X, you will go to some subset. And if you have the NFA and you are starting the NFA with the same string X, then you are going to some subset, and these two subset must be same. So this is actually, this conversion says that, and in the proof you can say that you need to show that Q1 delta 1 star Q1 X is equal to delta star Q0 X. This means if you say that if you start from the initial state of the DFA for the string X, you will go to some subsets of Q. Here also, starting from the delta star from the initial state Q0 of NFA, for the same string X, you will go to some subset, and these two subsets will be same, because you have defined the transitions of DFA on behalf of the NFA. So this must be true. Means delta 1 star delta 1 star delta 1 star must be equal to this thing. So trivial case is what? Trivial case is that if you have the X is equal to null, so you can show by induction. So how you can prove that this is equal to this? So see, you have the delta 1 star Q1X. Okay, we need to prove. So X is equal to null. We have taken for the is trivial string. So you can say that this is delta 1 star, and here is Q1 and null. And what by definition, if you go to definition of the DFA, what is the, if you are in the case of the DFA, if you are in any state of the DFA, and from that state if you receive the null string, you will go to the same state. And output of this is what? This is Q. So this is the output. And Q1 is what? We have seen that, we have assumed that Q1 is the initial state and Q1 is equal to Q0. So this means you can say this is equal to actually Q0. And what you mean by Q0 is equal to what? You can say that delta star, you are in initial state. Delta is the transition function of your NFA, and you have the null string. So by definition of the delta star in case of the NFA, if you are in some state and you are getting the null string, you remain in the same state, but you have to write in the form of subset, because you, in case of the NFA, you have the output is the some subset of the Q. So that's why here output is Q0, but Q0 you have to write in the form of the subset Q0. And that's why you can say that for x is equal to null, you can say Q0x. So Q1 delta 1 star Q1x is equal to delta star Q0x. So this is for trivial case. You know that cases hold. So actually, if you have this situation now, delta 1 star Q1 x is equal to delta star Q0 x. Okay. So now you need to show that if this is true, then for any a belongs to sigma, you need to prove that actually delta 1 star Q1 xa is equal to delta star Q0 xa. You need to show. So by induction, for x, you have seen that for x is equal to null, this condition holds. Then we need to take some bigger strings. So you can say that xa, a is some input from the sigma. So this should also hold. So you need to prove this. So how you can show this thing? It means you need to show that delta 1 star Q1 x xa. So if you are at the state Q1, delta 1 is the transition function of DFA. If you are at the state Q1 and you have the string xa, how you can define? By definition of the delta star in case of the DFA. So if you go for the DFA, then what you found? Means you can say that you have the delta 1 star Q1 x, then you have the A. So your definition says that delta star definition of your DFA says that if you are in some state and you have the string xa, where you can go? So you know that you need to know first on accepting the string x in case of the DFA where you are going. So here delta 1 is the transition of your DFA. Delta 1 star Q1x, you need to know that in which state you can go, and from that state, if you are receiving the input A, where you can go. This this is the by definition of your delta star of DFA. Now we have seen that delta 1 star Q1x. Okay, so delta 1 star Q1x, this is equal to, we have proved that delta 1 star Q1x is equal to delta star Q0x. So in place of that, you can say that delta star Q0x, and you have the A. Okay, so now see, delta star q0x, delta star q0x. Now delta is the transition function of your NFA. So if you are at q0 and I'm taking the string x, you will go to some subsets of q, some subset of q. So actually this is, and this subset is actually what? This subset is actually the state of your DFA. So this means, say, let this is the, you can say this is the q. If this is q. So how you have defined the transition function? So you have defined the transition function of DFA like this, delta 1 QA. So here the same, this thing is same, delta 1 QA. So delta 1 QA, and you have taken the help of the transition function of NFA. So this can be delta PA, where P belongs to the Q. So you can say by definition of the transition function of DFA, what you can say, this is equal to delta PA, and where P is what? P belongs to Q. So here you have the P belongs to Q, and Q is equal, actually this Q is actually delta star Q0 X. So this is the by definition of the transition function of DFA you have defined. So you can say that this is the, now this can be, this is what, this is equal to what, this is equal to, you can say that delta star Q0 X A, by definition of transition function of NFA. So you have delta is the transition function of your NFA, delta star Q0 XA. So this is the transition function of your, delta is the transition function of your NFA, and from Q0, if you are taking the string XA, where you can go, how you can define, you have defined your transition function says that you can go to some state from where P is what, where P belongs to delta star Q0X, means you need to determine first on receiving the string X from the Q0, what are the states your machine can go, and from those states you have the input A, and you need to decide from those states, you need to know that where your machine goes, and then make the union, and this will be the output. So delta star Q0XA is actually the same as union delta PA, where P belongs to the delta star Q0X. Now you have, by induction, you have seen that you have proved here. What you have proved? This delta 1 star Q1XA is actually equal to the delta star Q0XA. And now Q1 is the initial state of your machine, and if XA is in the language, then you know, if it is in the language, then this set and the set with A is the set of accepting state in the NFA, and this should not be equal to empty. So you have A is the accepting state of your NFA. So once you are starting from the Q0, whenever you are at the Q0 and you have the input XA, this is the subset, this will show the, this is output is some subset of Q, and if you make the intersection of this subset with A, and if it is not empty, then you can say that XA, this string belongs to the language accepted by the machine MA. And also, since we have defined the accepting state of your DFA in the same manner, so you can also say that X belongs to the language of M1, where M1 is the DFA. So you have proved that whenever you start from the initial state of your DFA and you supply some string, And whenever you start the initial state of your NFA for the same string, you are going to the same subsets of the Q. And if that subset contains the final state, then you can say that, okay, this is the string which is in the language. And hence, this is the way we have proved the theorem, which says that for any NFA M Q sigma Q0 A delta accepting a language else which is taken from the sigma star, or this is actually, instead of writing belongs to, you can say this is the subset of sigma star, because L is the set of string and you have the set of string. L is the subset. So for any NFA M Q sigma Q0 A delta accepting a language L which is the subset of the sigma star, there is a DFA M1 which is equal to M1. You can define M1 by writing the set of states. You have the same inputs: initial state, set of accepting state, and transition function. And the set of states Q1 is defined like this, initial state is defined like this, and transition function and accepting state is defined like this. And this is the way you have to convert the NFA into the DFA. So this is the conversion. Let us take one simple example. This is the language. We need to construct the DFA for this language. So in order to construct the DFA, we know that if you can construct the NFA, then later we can convert to the DFA. And how you can construct the NFA for this language? So this is very simple. You say you are in the state, say you are in the Q0. You are in the state Q0. This is the initial state. And if you construct the NFA, then you know that 0, 1 clean star, and this can be none also. So you don't worry for the situation. So either 0 or 1. If you are at the state Q0, if you have 0 or 1, you can repeat like this. This is the 0, 1 clean star. Then if you receive this one, then you can transit the state. So you can transit the state. Say you are going to the state Q1. You are in the state Q1, and for which input you have the 1. Now from the Q1, you can have either 0 or 1. And you need to remember that, because here is the 2, so you have to make the transition. So either 0 or 1. You can receive here either 0 or 1. Now you are going to the state Q2. Now from Q2 again you have either 0 or 1. And for 0 or 1 you are going to the state Q3. And this is the Q3, and you have 2 times 0, 1, 0, 1, 2 times, and hence you don't require further input, and this is the final state of your NFA. So this is the NFA. This is the NFA. Now how you can convert this NFA into the DFA? If you want to convert this NFA into the DFA, then how many possible states we should have? We can have 2 raised power q. This much possible states you can have. Means the Q1 in the DFA, Q1 is the state of DFA, and you have 2 raised power q. You have defined earlier that the states of your DFA are the subsets of Q, and this is the maximum possible states in your DFA. Now all such subsets may not be reachable from the initial state, and we are interested for those subsets of Q which are reachable from the initial state. That's why you have to start from the initial state, and then one by one you need to come to know that which states you are going to visit. So for that, actually you need to have the transition table. You have some state in the DFA. Now we are going to define the transition table of DFA. So you have some state. So you can say this is the some state. Okay. You have some state. Now you need to show the transition. This is delta 1 is the transition of your DFA. And if you are in some state, say you are in the state Q, and you are receiving the input 0, where you will go? You need to see. And you also need to consider, if you are at state q, and if you have the input 1, where you can go? So now see, and we know that you have to start from the initial state, and initial state of your DFA is what? Q1. Q1 we have seen that this is the initial state, and Q1 is equal to what? This is the Q0. This is the subset. So initial state of your DFA is Q0. This is the initial state. Now see how you are, this is the initial state, and means this is the state of DFA, and you have to define the transition on behalf of the NFA. So if you are at the state Q0, and you see that if you can get the input 0, where you can go? So if you are at the state Q0 and you have the input 0, where you are going? You are going to the state Q0. So only one state. So for the, if you are at the state Q0 and you have the input 0, you are going to the state Q0. Now if you are at the Q0 and you have the input 1, so see, if you are at Q0 and for the input 1, your machine can remain in the same place in NFA, or your machine can go to the Q1. So there are two possible states. So here you have the two possible states. One is Q0 and other one is the Q1. So this is the partial state. Means from Q0, if you take the input 1, if your DFA is given the input 1, it goes to this state. And you have to define the transition. You have seen the transition for 0 and 1 from this state. Now you have defined the transition for this state, initial state. Now you need to define the transition for, this is the new state you can reach from the initial state. So you can define the transitions. So here you have Q0, Q1. So now this is the new state of your DFA. So see, from the Q0, if you have the input 0, you are going to the Q0. So you are going to the Q0. If you are at Q0, input is 0, you are going to the Q0. If you are at Q1 and input is 0, so if you are at Q1, input is 0, you are going to the state Q2. So you are going to the state Q2. And hence, this is the, if you are at the state Q0, Q1, if you are given the input 0, your machine can go to the Q0, Q2. Now, if you are at Q0 and your input is 1, your input is 1. If your input is 1, then your machine can go to, if you are at Q0, input is 1, your machine can go to either Q0 or Q1. Now, if you are at Q1 and input is 1, if you are at Q1 and input is 1, your machine goes to Q2. So this is the Q2. So this says that from Q0, Q1 state, your DFA, for the input 0, it goes to this state, and for the input 1, it goes to the state Q0, Q1, and Q2. So you have seen the transition for Q0, Q1. This is the new state. Now you can show the transition for Q0, Q1. So see, Q0 and Q2. So Q0, Q2. So Q0, Q2. So how you can define the transition for this Q0, Q2? If you are at Q0, input is 0. If you are at Q0, input is 0. You are going to the same state. You have the Q0. If you are at Q2, input is 0. You are going to the state. So you are going to the state Q2. If you are at Q2. So if you are at state Q2 and input is 0, you are going to the state Q3. This is. Now, if you are at Q0, input is 1, you go to the state Q0 and Q1. If you are at Q0, input 1, your machine can go to Q0 and Q1. If you are at the Q2, and your input is 1, your machine goes to state Q3. So see, you have seen the transition for Q0, Q2. Now you can see the transition for Q0, Q1, Q2. So you have Q0, Q1, and Q2. So, okay. So if you are at the state Q0 and your input is 0, so your machine goes to the Q0. If you are at Q1, input is 0, your machine goes to the state Q2. If you are at Q2, input is 0, your machine goes to the state Q3. So if you are at state Q0, input is 0, your machine goes to Q0. If you are at Q1, input is 0, machine goes to the Q2. From Q2, 0, it goes to the Q3. This means your DFA from this state, for the input 0, it goes to this state. Now you can define the transition for the case of 1. If it is 1 from the Q0, your machine, your NFA goes to Q0 and Q1. If you are at Q0 for 1, it goes to Q0 or Q1. If you are at Q1, and input is 1, your NFA goes to Q2. If you are at Q2, input is 1, your NFA goes to Q3. So this is the state your machine goes when you have, for the case of 1 from this state. Now you have seen the transition for Q0, Q2, Q0, Q1, Q2. Now you need to show the transition for this state. If you are at Q0 and Q3. If you are at Q0 and Q3, so if you are at Q0, for the input 0, your machine goes to the Q0. If you are at Q3 and input is 0, where your machine goes, where your NFA goes, it goes to the empty state, means null set. And once you make the union of Q0 and null set, the set remains same. So for the case of 0, you go to the Q0. So from Q0, you have the 0, you are going to the Q0. From Q3, 0, empty state. Now for the case of 1, if you are at Q0, your NFA goes to Q0 and Q1. This is the state. And if you are at Q3, if you are Q0 for 1, Q0, Q1. If you are at Q3 for getting 1, and you know that there is no transition here at the Q3 for 0 or 1, means machine goes to the empty state. So you can say empty set, and once you make the union of that empty set with this, so this is the, and see, you have seen the transition for Q0. You have given the transition for Q0. Q0, Q1, you have also given the transition Q0, Q1. So this is transition of this state is also over. This is not the new state. Now, which state remaining? You need to give the transition for this state. So you have Q0, Q1, Q3. Q0, Q1, Q3. If you are at this state, Q0, Q1, Q3, then where you go? So if you are at Q0, input is 0. If you are at Q0, input is 0, your machine, your NFA goes to the state Q0. If you are at Q1, input is 0, your machine goes to the state Q2. If you are at Q2, input is 0. Q3, input is 0, your machine goes to the empty state. So if you make the union, then this is the state. Okay. So from Q0, you are Q0 for the input 0. From Q1 for 0, you are going to the Q2, and from Q3, you are going to the empty state. So this is the, now for the case of 1, if you are at Q0 and input is 1, your machine goes to the Q0 and Q1. If you are at Q1, input is 1, your machine goes to the state Q2. If you are at Q3, input is 1, your machine goes to the empty state. So this is that. So Q0, Q2, you have defined the transition Q0 and Q2. So this is not the new state you have defined. Q0, Q1, Q2. Q0, Q1, Q2. You have also defined the transition for this state. Means this is also not a new state. So you have two states remaining. You have to give the transition Q0, Q2, and Q3. So you need to give the transition Q0, Q2, Q3. Q0, Q2, Q3. If you are at this state, Q0, Q2, and Q3, then what happened? So see, whenever you are at this state, whenever you are at the state Q0, for the case of 0, your machine goes to the state Q0. Whenever you are at Q2 and input is 0, you are going to the state Q2, input is 0, you are going to the state Q3. Whenever you are at Q3 and input is 0, you are going to the empty state. Q0, Q3, this is not the new state. You have defined the transition here. So this is the old one. Now if you are at the Q0 and you are receiving 1 from the Q0, so you have the Q0 and you are going to the Q1. Now from Q2 and getting 1, you are going to the state Q3, and from Q3 getting 1, you are going to the empty state Q0, Q1, Q3. So Q0, Q1, Q3, you have already defined the transitions. This is not the new state. So only state remaining is this. So you can give the transition for this state, and this is the Q0, Q1, Q2, and Q3. So okay. So Q0, Q1, Q2, and Q3. So this is the one state you have. So Q0, Q1, Q2, Q3. If you are at Q0 and getting 0, you are at Q0. If you are at Q1 getting 0, going to the Q2. If you are at Q2 getting 0, going Q3. Q3 getting 0, empty state. Q0, Q2, Q3. Q0, Q2, Q3. You have already defined the transition. So this is not the new state you have already defined. Now for the case of 1, if you are at Q0 and getting 1, Q0, Q1. If you are at Q1 and getting 1, your machine goes to the Q2. If you are at Q2 getting 1, your machine goes to the state Q3, and Q3, for the case of 1, your machine goes to the empty state. Q0, Q1, Q2, and Q3. Q0, Q1, Q2, and Q3 you have already defined, means transitions are over. So see, these are the only transitions, these are the only states of your DFA. So how many states you have now? You have, this is one state, 1, 2, 3, 4, 5, 6, 7, and 8. So you have only 8 states in the DFA. However, if you according to this definition, Q1 is equal to 2 raised power Q. Cardinality of Q is what? 1, 2, 3, 4. You have the 4 number of states. So what are the possible states we have seen? What are the possible? 2 raised power 4 means 16. It should be 16. 2 raised power 4. Okay. So 16 possible states are there. 2 raised power 4 because you have the 4 states in the NFA. So 2 raised power Q has 16 elements. However, out of these 16 states, possible states in the DFA, you can reach only these 8 states starting from the Q0. So once your machine starts from the Q0, and for getting any input 0 or 1, your machine can reach only these states, and other states of the DFA cannot be reachable, and hence we ignore that those states. So these are the only states of your DFA. So this is the way you can construct the machine. And finally, you can consider this as the states. Like this is one state of your machine. So say you can say that this is the state Q0, and here we are writing in the form of set. So this is one state of your machine. This is one state, and this is also the initial state of your machine. Now say for the case of 0, your machine goes to the same state. If you are at the state Q0 and for input is 0, your machine goes to the same state. So here you can make the transition, and for the input 0, it remains in the same state. Now for the case of, if you have the 1, if you are at the state Q0 and if you have the 1, then where you go? You are going to the Q0 Q1. So you are going to the state Q0 Q1. This is the subset you are going, and this we mean that this is one state. This is one state. Okay, and for this state you are going for which input? For the case of 1. So for the input 1, you are going to the state Q0 Q1. Now once you are at state Q0 Q1 and you have the input 0, you are going to the state Q0 Q2. So you can write here somewhere else. This is, say for example, Q0 and Q2, and this is one state of your DFA. So your machine goes to this state for the input 0. So if you are at Q0 Q1, if you are at Q0 Q1, input is 0, you are going to the state Q0 Q2. Okay, and if you are getting the input 1, your machine goes to Q0 Q1 and Q3. So okay, for the case of this, you can draw here somewhere else. So this is the, you can write here Q0 Q1 and Q2. So this is the subset your machine goes. Okay, and this is one state. This is the state of your DFA. So for which input you are going? If you are at Q0 Q1, if you are at Q0 Q, your input is 1, you are going to the state Q0 Q1 and Q2. So this is for the case of 1. So this is so for the case of 1, you are going to the state this. Now say you have seen in the case of, to here you have seen. Now you have, if you are at the Q0 Q2, if you are at Q0 Q2 and your input is 0, you are going to the Q0 Q3. So for the case of 0, you can write somewhere else. Say you can write here Q0 and Q3. So this is one state you have, and this is the state. And so see, you are going from here to here. If you are at Q0 Q2, and your input is Q0 Q2, input is 0, you are going to the state Q0 Q3. And if you are at Q0 Q2 and input is 1, you are going to the state Q0 Q1 Q3. So for the case of, you can write here Q0 Q1 and Q3. So Q0 Q1 and Q3. This is the state. So you have this, and here you are going for the this state for the case of 1. So now you have seen that if you are at q0 q2, then for the case of 0 you are going to the q0 q3, and for you are going to the state q0 q1 and q3. Now you can see that if you are at, you have seen the transition for this, now you can see the transition for this. So if you are at q0 q1 and q2, if you are at q0 q1 q2, and for the case of input 0 you are going to q0 q2 q3. So you can write here somewhere else q0 q0 q1 q0 q2 q3 q2 and q3. This is one state, and you can mark this as the state like this, and this is you are going for the case of 0, and for the input 1 where you go, for the input 1 you are going to q0 q1 q2 and q3. So q0 q1 q2 and q3. So this is the state you are going, and you can mark circle, and this state you are going for the case of 1. Now you have seen that if you are at state q0 q1 q2 q0 q1 q2, for the input 0 you are going to the state q0 q2 q3, for the input 1 you are going to the state q0 q1 q2 and q3. Now you have seen the transition, you can see the transition from the q0 q3. So whenever you are at the q0 q3, for the case of 0 you are going to the state q0. So here from this state, for the case of 0 you are going to the state q0. So from q0 q3, for input 0 you are going to q0. For if you are at q0 q3 and input is 1, you are going to the state q0 q1. There is q0 q1. So you are going to the state this q0 q1. Okay. So for the input 1, you are going to the state this. This is for the case of 1. So now you have seen that if you are at the q0 q3, for the input 0 you are going to q0, and for the case of 1 you are going to the state q0 q1. Now once you are at the state q0 q1 q3, you can see, so if you are at this state q0 q1 q3, input is 0, you are going to the state q0 q2. So okay, you can see here, yeah, you can see like this, you are going to the state from q0 q1 q3. For the input 0 you are going to the state q0 q2, and for the case of 1 q0 q1 q2, q0 q1 q2. So you are going for the case of 1, you are going to the state q0 q1 and q2. So see from the state q0 q1 q3, for input 0 you are going to the state q0 q2, and for input 1 you are going to the state q0 q1 and q2. Okay, now which this the state q0 q2 q3 is we have to give the transition. So once you are at the state q0 q2 and q3, for input 0 you are going to the state q0 q3. Where is q0 q3? So okay, so you are going to the state here, sorry, you are going to from the state q0 q2 q3, q0 q2 q3, for the input 0 you are going to the q0 q3, for input 1 you are going to the Q0, Q1, Q3. Q0, Q1, Q3. So for the case of 1, you are going to this state. So this is for the case of 1. So for now you have seen the transition. If you are at the state Q0, Q2, Q3, for input 0, you are going to the state Q0, Q3, and for input 1, you are going to the state Q0, Q1, and Q3. Okay. Now the only state remains is Q0, Q1, Q2, and Q3. If you are at Q0, Q1, Q2, Q3, and input is 0, you are going to the state Q0, Q2, Q3. Q0, Q2, Q3 for the case of 0. Okay. So for the 0, you are going to the state this Q0, Q2, Q3. Now, if you are at Q0, Q1, Q2, Q3, and for the input is 1, you remains in the same place. Q0, Q1, Q2, Q3 for input 1, again same. So for the case of 1, you are remain in the same place. Now see, this is the way you can transit. This is the transition function of your DFA. So you have obtained the DFA corresponds to the given NFA. Now one thing is remaining. You have to show that which one of these states are the final state. So which one is the final state? You have to make the intersection with the A, and A is what? A is what? A is equal to, actually it contains the state only Q3. So make the intersection of, say you can make the intersection of this side with A. It is empty, so it cannot be final state. Q0, Q1, if you make the intersection with Q0, Q1 with and A, it is also empty. Q0, Q2, empty, disjoint set. Q0, Q1, Q2, and Q3, these are also disjoint set. Once you make the intersection with Q0, Q3, and with Q3, it is not empty. You have the common element here, Q3. So this is the final state. Q0, Q3 is final state. Also, Q0, Q1, Q3 is also a final state because intersection is not empty. Q0, Q2, Q3 is also final state. Q0, Q1, Q2, Q3 is also final state. So you have the 4 final state. So this means this is the final state of your machine. Okay. This is also a final state of your DFA. This is the final state of your DFA. This is also a final state of your DFA. And this is also the final state of your DFA. So you have 4 final states now. So this is the way you can convert the NFA. You have converted this NFA into the form of DFA. So this is the DFA. This is the DFA. So you have NFA, and from NFA you have obtained the DFA. So you have seen. Now after doing this, if you wish, you can rename the states of your DFA, and like you can say this can be renamed as the simple one. So you can say this is the simply like A, B, C, D, and you can say E, F, G, H, or any states in your interest. So once you have constructed the DFA, once you have obtained the states of the DFA, then states of your DFA may be any subset of Q. And later you can rename these states and you can write the simple name for these states. After identifying the final states and construction of the DFA, you can rename it. So this is the way you can obtain the NFA from NFA you can obtain the DFA. And hence this shows that every NFA can be converted into the DFA. So in this way, you can say that power of NFA means the set of language accepted by the NFA, and power of DFA means set of language accepted by the DFA. So since you are able to convert every NFA into the DFA, this means power of these two machines are remains. It means for any language, if you have some NFA, then you will also have some DFA. So NFA and DFA are equivalent in the sense of accepting the language. So power of NFA and DFA are same. The set of language accepted by the NFA is the same as the set of language accepted by the DFA. So this is the way we can obtain from the NFA into the DFA. Okay. This actually conversion is very simple, but you have to remember that you have to give the transitions of DFA on behalf of the NFA. And most important thing is that having, instead of listing all possible states of 2 raised power q, you have to start from the initial state, and one by one you can see that which subset you can visit from the initial state, and the subsets that can be reachable only from the initial state, that you have to consider only for the states of your DFA. The states that cannot be reached from the initial state, you can discard. So you don't require to list all possible subsets initially. You just make a table like we have done in this case, and one by one you can obtain the states and give the transitions. When there is no new states remains, you can stop, and these are the only states in your DFA that can be reached from the initial state.